We will now proceed to the properties of vectors in R squared or in R cubed. So they are just two-dimensional and three-dimensional spaces. If U, V, and W are vectors in R squared or in R cubed, and C, D are real scalars, then you have the following property. First, vector addition is commutative. This means that U plus V is equal to V plus U. So the order of vectors doesn't matter in addition. Second property is that vector addition is associative. Third property is that the vector u plus the zero vector is just the zero vector plus the vector u. So they are commutative here, and so that is equal to the vector u. So meaning any vector added to the zero vector is the vector u. So it doesn't affect the vector u. Fourth, this is vector u plus the negative of the vector u is the zero vector. This one means that the scalar quantity is distributive over the sum of two vectors. That is c times the quantity vector u plus vector v is equal to c times vector u plus c times the vector v. Okay, so the sixth property means that a vector is distributive over the sum of two scalars. So for this one, okay, so the quantity c plus d times the vector u is equal to c times vector u plus d times vector u. Okay, then number 7 is multiplication of scalars is associative. So here, so c times the quantity d times scalar u is equal to the quantity c times d times the scalar u. And then for the eighth property, the 1 times any vector is equal to the same vector. Okay, so 1 times vector u is equal to vector u. Geometrically, we have this as an example. Let us consider this vector u, whose components are -2 and -4, and vector v, whose components are 4 and -3. So we show here that u plus v is equal to v plus u. So this is just a particular example, no? So this is not the proof. So this is just to show you how these vectors satisfy this equality. All right. So first we show vector u plus vector v. All right. So vector u plus vector v. V is just that the tail of vector v is connected to the head, the vector u. So we get the sum of vector u plus v. That is this vector with components 2 and -7. So for vector v plus u, okay, ito si v, connect natin si u. The result is this vector, and that vector is 2, -7. It's the same with this one. Therefore, these two vectors are equal. Okay, so this one is associativity of vector addition. Let us consider these three vectors. So in this side, we show that u, the quantity u plus v plus the vector w. So unahin muna natin i-add si u at saka si v. So this is vector u plus vector v. Okay, so i-connect natin doon sa vector u. So the result is this vector. Yan, this is the sum of the two vectors plus vector w. So ito yung ating u plus v, we will add to this vector, the vector w. Alright, so vector w. Alright, so that is now this vector, the u plus v plus w. On this side naman, so we add first v plus w. So this is v, this is w. So v plus w, this is the vector v plus w. We add to this vector the vector u. Okay, so take note, no, yung i-add natin sa u ay ang vector v plus w. Ito yun na vector. So we will add that to u. Oops, nasira. Alright, so ito na lang i-transfer natin doon. Ayan. So this is now the vector u plus the quantity v plus w. So if you observe, they have the same components and therefore these two vectors are equal, satisfying this equality. This one shows that there is a zero vector, in this case in r squared, okay? The zero vector is this vector, such that if you're going to add this one to any vector u, the result is still the same vector. So kung i-add natin yan siya, yan, so the result is still vector v. This one says that for any vector v, right, this one here, there is an additive inverse w such that if you're going to add the two, right, the result is the zero vector. So find the inverse w such that v plus w is equal to the zero vector. So hanapin natin ano kaya yung vector na yan. So let us try. We're going to add this one to the vector v, right? So in this one, the result is not still not the zero vector. So kapag ganyan ka, wala pa rin tayo nakuha na zero vector. So this one here is the negative or the additive inverse of the vector v. Ibig sabihin, ito na vector, okay, with the component 6, 2, if you're going to add that to the vector w, so the vector w, the negative or the additive inverse of vector u has components negative 6 and negative 2. If you're going to add the two, the result is the zero vector. And if you're going to observe, they have the different direction. So the negative of this vector is the vector that has the opposite direction with this vector. In this case, that's vector w. In here naman, we show the quantity r plus s times vector v is equal to rv plus sv. So let us consider this particular vector. Our r in this case is 1 and our s is equal to 1 also. So if you observe, that is just the vector with component 6, 4. Okay. And on the right side, the RV and SV, so it's just 1 times V, so V pa rin, plus 1 times V, still V. That is this vector. So this is 1 times V or 3, 2 plus, i-connect mo lang yung SV dito sa vector na ito. So the result is a vector from this point up to this point. And if you observe, that is just the same with this vector with component 6, 4. Okay, so ito naman kapag i-add mo, 2, that is 3 plus 3, 6, 2 plus 2 is 4. So it has the same component with this vector. Let us try to increase the value of S. Alright. So, increasing the value of S, napapansin ninyo, no? Ayan. So, this one increases the value of S. So, this one also is scaled 2.5 times. 2.5 times this vector. So, mas humaba siya, no, ng 2.5 times compared to this one. And the result, okay, ito, the result is still the same with this vector here. They have the same components also, right? So if we increase the value of r, alright, so tingnan ninyo kung ano yung nagiging effect, no, doon sa ating mga vectors. Okay, so our r here now is changed to 2.5. In this case, the value of b in here is also scaled 2.5 times. In effect, the resulting vector is the vector from this point up to this point, which is the same as this one. Okay? Dito naman, we will show that the r times the quantity v plus w is equal to rv plus rw. In here, we consider this vector, the r times v plus w. So, dito, yung green yung ating vector v, yung blue naman ang ating vector w. The sum of that, okay, so this is v plus, so i-connect mo yung w dito, so the resulting vector is v plus w. Ito yun siya, yung pink, or that is this vector here. Okay, on this side naman, this is our vector u, this is our vector v. So the sum of that is this vector, so it's equal to this one. 1 times v, this is 1 times w. This is just equal to v, this is just equal to w, because our r in this case is just equal to 1. So if r is equal to 1, the ito at saka ito are the same vectors. If we try to increase our r in this case is 1.25. Alright, so our r is 1.25. So for v plus w, ito yun siya. The 1.25 of this vector times that vector, meaning you scale this vector 1.25 times. Ibig sabihin, isa at saka 1/4 nito. That is this vector. Dito naman na side, okay, so it means, this one means that you scale vector v 1.25 times. So, kung napapansin nyo, itong green, sumobra siya, no, ng something like 0.25. So, the length, this vector from this point up to this point, okay, is scaled 1.25 times compared to this vector v. Sa vector, vector w, that is this vector. So this vector is scaled also 1.25 times. That is why its sum is a vector from this one up to the head of the vector w. And if you observe, this vector and this vector are equal. If we try to increase again our r, so kung i-increase pa natin yung r natin, okay, so increase natin yung r natin, so same pa rin siya ng result, and so on. Okay, so in this case, our r is 2. Alright? So, ibig sabihin, that our